Hey guys, so in this video I wanted to run through how you should have gone about solving the mole 1. It was the first assignment I gave you just in this unit, this quarantine unit called the mole with some new stuff. So I just re-released the assignment as you guys saw, and then what I wanted you to go back through and do is gaining the skills that you did in 2, 3, 4, and 5. What I wanted you to see is, well, can you do the mole 1 now more accurately? So let's roll through that. Part 2 is what I was asking you to focus on. Not the baking the pizza part, but the second part with Coca-Cola. The first thing that you really had to do is you have to figure out how much sugar, or what this molecule, what table sugar is actually called a sucrose, is ingested per sip that you take. Remember, and that's kind of key that it's per sip. So we got to be able to figure that out. Or really what we want is the unit sugars per sip, or sugars over 1 sip. That's what we're looking for. The second thing that we have to figure out here that's a challenge is you want to determine how many molecules of sugar or sucrose are in each sip. Right? Here's a hint that I think is really helpful for helping you solve some of these problems. Reword the question in chemistry language. What are we learning about currently, and then how can you go about applying it to the situation that we're in? So think about the tools that you have, right? And that kind of helps. Here's the way that I might reword it. You want to determine how many molecules of sucrose are ingested per sip of Coca-Cola. To do this, you need to know a few things. You might even stop the video here and think about, well, what were the things that I needed to know to be able to do this? And then how can I go about finding them? So what I came up with are, you need to know the formula of sucrose. Now, the main reason you want to know the formula of sucrose is you need to know what atoms are in it so that you can add up and get the molar mass of sucrose, or how much 1 mole of sucrose weighs, right? The mass of it. Another thing that we'll want to figure out is how many grams of sugar are actually in a 12-ounce can of Coca-Cola. Where could you find that information? Next, how many sips are in 12 ounces? Now that's what I'm asking you to determine experimentally, right? Which should be kind of fun to experiment with. So here's what I went and did is you can just use Google, let Google be your friend. And what I found is that there are 39 grams of sugar in a 12-ounce can of Coca-Cola, right? And that just came directly from Googling it. You could do the same thing. You could Google, or you could grab a 12-ounce can of Coca-Cola and look and see that there's 39 grams. That's the first thing that we want to do. So we've got that question answered. We know how many grams are actually there and present in a can of Coca-Cola. Now the next thing that I wanted to do is I wanted to look up the formula, and you guys can see the formula is actually right here. It has 12 carbon atoms, it has 22 hydrogen atoms, and it has 11 oxygen atoms. You put all that together and we call that the molecule sucrose, or table sugar. The molar mass then is actually like an added bonus that it's right here. If you took those 12 carbons and you took the 22 hydrogens and you took the 11 oxygens and you added them all up, you would get a number right around 342.3 grams per mole. So if I took 342.3 grams and I measured it out, I would have 1 mole of sucrose molecules, or 6.02 times 10 to the 23rd molecules is what I would have. Okay, so we got the formula of sucrose, we've got the molar mass of sucrose. Now what we really need to do is figure out how many sips are in 12 ounces. Well, that's pretty easy. Get 12 ounces or a can of Coca-Cola and count how many sips it takes you to finish. For me, it took 15. For you, maybe it took 20. Maybe it took, I don't know, 8. You have to count that and determine that number experimentally. And for me, that was 15, and there can definitely be some variance there depending on, how much you sip, right? There's no direct answer to that. Okay. So I've got 15 sips per can. This is now my information just listed out so I can work with it a little bit easier. This is all my data. So I've got the formula right up here. I've got the molar mass right down here. I know that there's 39 grams of sugar in one 12-ounce can, and I know that it takes me 15 sips. Now, how could I figure out one of these things? Like, what's my first calculation? Well, my first calculation should probably be to figure out how many grams are there in every single sip. So if there's 39 grams total and it takes 15 sips, then really all I have to do is take 39 divided by 15, and I can figure out that I actually ingest 2.6 grams per sip that I take. Okay, so that's a great number, 2.6 grams per sip. Now what can I do with that? Well, remember, what we're trying to do is figure out how many molecules are there per sip. Well, now we know we can go from grams to moles to molecules, and that's exactly what I'm doing with this down here. I've got 2.6 grams of my sucrose for every 1 sip. I want to then convert that into moles. So the way that I'm going to do that is I'm going to put 1 mole of sucrose over the molar mass of sucrose. Now the grams will cancel, and if I stopped my calculations here, I'd have my number of moles of table sugar. But I want one more conversion. I want to go from moles of table sugar to number of molecules, right? And we have some units that work for that as well. So every 1 mole is 6.02 times 10 to the 23rd molecules. Now, do I have a full mole of sucrose over here? No, I only have 2.6 grams of it. 2.6 over 342.3 grams, that's not a lot, a very small fraction of a mole. But we're going to take that number and then multiply it by 6.02 times 10 to the 23rd molecules, how many there would be if we had a full mole. And I get the answer of 4.6 times 10 to the 21 molecules for every single sip you're taking. That is a massive amount of molecules that you're ingesting of table sugar for every single sip that you take of a can of Coca-Cola. That's an amazing amount, right? That's a very, very big number. A thing to pay attention to here is, did you actually get the units? Did you give me units? Did you circle your answers? Was your answer here on only 2 significant figures? Did those 2 significant figures ultimately come from because you had 39 grams and you took 15 sips? Are you using those really small things to get a very precise answer? Remember, I just don't want an accurate answer. I want a precise answer. This is about accuracy and precision in chemistry. So make sure that you're doing that, okay? Now, how was this scored? Well, 10 out of 10 if you got everything correct. No errors. So based on your data, it was very easy for me to see exactly how you calculated this. You got a 10. You got a 7 if you made some errors, but you gave it a try, right? Like you gave it your best shot. But you didn't quite get there. So maybe your sig figs were off, maybe you didn't have units, maybe you just kind of had the wrong strategy. There's multiple ways to solve it, but maybe you just didn't get to the answer. And you just got a 0 if you didn't submit anything to be graded. Those are the only grades that we have. Remember, you can check that out with the grading policy that we have for term 4. And we adjusted just because we're in this really weird situation. Remember that I'm also asking for feedback on the Google form here for our next unit. One thing that you were asking for that's pretty consistent right now is a little bit maybe extra practice, like you guys missed the homework sheets. I'll figure out a way to do that because one of the positives is you're liking the pace of the class and you're liking that I'm not giving too much at any one particular time. So how to balance those things, I've got to think about a little bit here. Our next unit, or our Q2 unit, is going to be on chemical reactions. I will release the first part of that tomorrow. Best of luck to you guys. Remember, if you have any questions, I have office hours. I hope you're all doing well. I really miss you guys. You were such a wonderful group of kids to teach. I was really enjoying being around you guys. And it's a bummer that we're still here in quarantine. But I hope you guys are figuring everything out and that you're staying safe and that you're happy and you're healthy. Best of luck, and I'll talk to you guys soon.